Opposite operations. So what's the opposite operation to multiply? Divide. What's the opposite operation to subtract? Addition. Easy peasy, right? So the opposite operation to a power is a root. Okay? So we're getting into the exponents, and you guys learned your exponent rules in grade 9. They were really kind of important because they're going to be super helpful for you. Okay, so if you have something to the exponent 5, you can actually apply a 5th root to it. So we've probably only dealt with square roots, and now we're going to kind of expand that a little bit bigger. So what this means is that I'm going to take what number multiplied by itself 5 times gives me 32. So 1, 2, 3, 4, 5. What number, when multiplied by itself, gives me 32? And I mean, we could guess and check and we can do all that stuff, but you can do it in your calculator, because essentially this is what it's asking. The 5th root of 32. So 1, 2, 3, 4, 5. What number, when multiplied by itself 5 times, will give me 32? And if we put that into our calculator, the answer is 2. The X on it, yeah. It should be a second function. So let's try that in our calculator. Okay, so everyone needs to grab their calculators. I'll grab 2 different calculators. All right. Okay. So you guys are looking for the multiple root button. So, sorry, this one's, let me turn on the light here. Kind of hard to see on mine. Mine's a little bit different. Mine has a filled in square, then a root sign, then an empty square. Do I have a different one? No, I just got 2 of the same. Snake, can I grab your calculator for 2 seconds? Another calculator, you'll see, it's kind of hard to see because I can't zoom in on it, but there's a cubed root one here, and then y to the exponent x, the second function above that is the x root y. That's your multiple root button. Okay, so what we have to do in our calculator first is we have to put in what type of root we want, and we want a 5th root. We want a 5th root. So we're going to type in the number 5, and then we're going to hit our multiple root button. So second function usually, and then I'm going to put in 32, the number under the sign, and then I'm going to hit equals. And I should get an answer of 2. So you guys got to figure out in your calculator how it works. Like, this is a chance for you to figure that out. Because you know what the answer should be. It should be 2. So you got to put in the number 5. You got to tell it what kind of root. And then you got to say what's under the root sign. And then you're going to hit equals and you should get 2. Okay, for you on your graphing calculator, you're going to go under math and you're going to pick option 5, but you have to put your 5th root in first. So 5, math, option 5, and then 32. Did you put in your 5 first?
Yeah.
What button are you using?
This one.
Should be this one, right? So 5, second function, that, 32. That's not working.
Yeah, I want to write degree.
You don't need that. We're not doing angles.
My calculator on.
Then you should invest in a new one.
It's brand new though.
You should invest in one that works. Okay, so in yours, you put the thing in that's under the root sign first. So 32,
Yeah.
second function, multiple root button, and then put in your index, the type of root. Okay?
Thank you so much. I really appreciate it.
It does error when I do it.
Okay.
Wait,
Can I
hold
see
on.
yours?
It just changed.
No, it didn't.
So 35.
No. Look at the number. Look at the number. You could even look at the screen.
No,
What number is it? Is it 35?
no, 32.
Right.
How'd you do it?
So 5, you got to put in the type of root first.
Yeah.
Second function, this button here, the y equals x.
Oh, so I don't have to put in the brackets, I guess.
No, you should be okay with it then.
Darn, I put in the brackets.
Okay, so what that told us was that with the 2, what it means is 2 times 2 times 2 times 2 should give me an answer of 32. And repeated multiplication can be written as an exponent, right? We keep the base at 2 and we just count up how many times we multiplied it by itself. And that's 2 to the exponent 5. Do you guys know how to use your exponent button on your calculator? Yeah, everybody's good with that one? Okay. All right, so here's a couple of things. So the square root of 64 is 8, because 8 squared is equal to 64. Now, if there's no number indicated, we know that that's a regular old square root, just a plain old square root. It's the invisible number 2, which is weird because we usually have invisible number 1s. This is called a cube root because 4 cubed is equal to 64. And fourth root, so a fourth root of 81 is equal to 3 because 3 to the exponent 4 is 81. So it's kind of like these opposite operations back and forth together. All right, so things you need to know about a radical. Radical is the name we give to the whole thing. The whole thing is the radical. This whole thing is called a radical. That's your type of root you have and the thing under the root sign. That whole thing is called a radical. Okay, the index tells you the type of root. So is this a square root? Is it a cube root? Is it a 21st root? So the index tells you what type of root you're doing, and the radicand is the stuff under the root sign. So I think in our mathematical careers up until this point, we've only ever dealt with square roots. We're going to kind of expand that now in this unit. Oh, okay. All right. So this is what you learned in grade 9 was about powers. So powers, when I talk about a power, that's the whole thing. That's the big base number and the little exponent. So we don't say 3 to the power of 4, we say 3 to the exponent 4. The power represents the whole thing together. All right, so if it has no brackets, there's only one thing that makes up the base number. If you have brackets, then there's more than one thing that makes up the base number. And I'll try to, oh, there's an example here. So let's say I have this. I have 1 over 2 squared. Let's say I just have that. So because there's no brackets here, what's squared? Is it 1/2? Is it the 1 or is it the 2? It's just the 1. So what this would mean is 1 squared over 2. If I want the 1/2 squared, I have to put brackets around it and say, hey, I want both the denominator and the numerator squared. Does that make sense to everybody? So we got to use brackets. All right, calculator time again. I want you to put this in your calculator. -3 exponent 2, and I don't want you to use brackets. So I'm going to put in a -3. It shouldn't.
I don't even have an option to use brackets.
So if I put just -3 in, if I put -3 and no brackets around it, I get an answer of -9. So I want you guys to try this on your calculator.
I don't even have an option for brackets or anything, I just put some -3, exponent,
Yeah, that's exactly what I asked you to do.
I get +9.
Where's if I put in a minus sign, as in 0 minus 3 squared?
Okay.
But
Okay,
I just
weird,
got a
but okay.
+9 though.
Yeah, if I just put in the minus sign before that.
So are you using the negative button?
Yeah.
Oh, it does do it for you. So weird. Okay. All right. Okay, so what this does is this should give you a -9 for an answer. And the reason why is because there's no brackets around the -3. So what your calculator thinks is, hey, I'm going to leave that negative out there, and I'm going to take 3, and I'm going to times it by 3. So your calculator ends up giving you a -9. Now, some of you are telling me that your calculator doesn't, which scares me a little bit, but because we need to know that this, if there's no brackets around it, means this. Because that may be a question I give you on a test or a quiz, and you should get an answer of -9. Now, if we choose to put brackets around the -3, your calculator now sees it like this. So what's -3 times -3? +9. So that's a little bit different. So I'm just going to use my calculator here. I'm going to open up my brackets, put in -3, close my brackets, and I'm going to hit the squared button. And now I get an answer of, kind of hard to see, +9 there. So they mean different things, so make sure you're using brackets appropriately. So that's going to have an answer of +9. So they mean very different things. And your math has to represent that when you're putting that together for me. Okay, super important. Because if you write this and tell me that the answer is +9, I'm going to mark you incorrect. Because that's not true. If you put -3 in brackets and say it's squared, that's true that the answer is +9. So just keep in mind brackets do make a difference and they say some different things. All right, so now you're going to have to commit some stuff to memory. Perfect squares. Do you guys remember what this means? No?
Yes.
So that means perfect square. What's 1 squared? 1. What's 2 squared? 4. 3 squared? It's in the list. 9. 4 squared. 16. And that keeps going on. I'm going to tell you, ladies and gentlemen, by the time you leave grade 10, you're going to be able to know your perfect squares. You should know your perfect squares up to 9. Well, up to 10. 10 squared is 100, so we can throw that one in. Perfect cubes are a little bit harder because we've never done those before. So that is 1 to the exponent 3. So that's just going to be 1. 2 to the exponent 3. That does not mean 6. A lot of people get that mixed up. That means 2 times 2 times 2. And if you do that, you get an answer of 8. And so 3 to the exponent 3 means 3 times 3 times 3. So that's going to be 27. 4 to the exponent 3 is 64. It's not 12, right? Because with exponents, that tells you about repeated multiplication. So 4 to the exponent 3 means 4 times 4 times 4. So that's the stuff, ladies and gentlemen, that you guys should have learned in grade 9. And I mean, last year was a bit of a crazy year. So if you're not as familiar with these, that's okay. Okay, so now we're going to use our calculators. So base number tells you what number you're multiplying by. The exponent tells you how many times you're multiplying it by itself. So 4 times 4 times 4. Okay, chart here, super easy to fill in. What's the square root of 16?
4.
4. Because that value ends, or in math we like to call that terminate, because that number terminates, that means it ends, it doesn't go on, it's not estimated in your calculator, we call that an exact value, okay? If you were to do the square root of 27 in your calculator, so I want you all to do 27 in your calculator. Root of 27. So we all should get that answer that's on the page, right? So does that decimal terminate? It does on the screen, right? Like, because I mean, eventually it has to terminate. Are there any patterns in that? Like, is there a repeating number or a repeating set of numbers? No? Do you guys remember what that kind of number is called? Where it doesn't end and it has no patterns in it? Nope. Radicals are the roots. Yeah, Rahat?
Irrational.
It is an irrational number. Good job. So an irrational number is something that doesn't repeat, like there's no repeating pattern in it, and it doesn't end. I mean, obviously your calculator has to end because the screen's only so big. So because that's an irrational number, we call that an approximate value. Okay? Now this one. Fractions are your friend and they're going to be super helpful for you. 16 over 81. I would leave it as a fraction. I wouldn't do it as a decimal. Because when I look at these numbers, is 16 a perfect square?
Yes.
Is 81 a perfect square? Yes, it is. So this could be written like this too. Could be written like that. So what's the square root of 16? 4. Square root of 81? 9. So we'd leave it as 4/9, or if we did it in our calculator, because all of you want to use your calculator, I'm sure. And I'm going to have 16 divided by 81. I got to close my brackets. I got to close my brackets in my calculator. And then I'm going to hit the equal sign. And is this an irrational number? Like it doesn't end, but what's different with this one? It has a pattern, it repeats. So this is an exact value. All right. What place value is that in?
10.
That's the hundredths place, right?
Wait, what?
Pretty simple question. What place value is the 4 in? Okay, it's in the hundredths place. So that's 2 decimal places. Is 100 a perfect square? It is. Is 10 a perfect square? Go back up to your list.
Oh, you meant like.
Yeah, is 10 a perfect square? Is it in this list anywhere? No, it's not. So 10 is not a perfect square. But because this is in the hundredths place, is 64 a perfect square? Yeah, it is. So if this is in the hundredths place, we know 100 is a perfect square. We know 64 is a perfect square. I can do this without a calculator. What is the square root of 64? 8.
0.8.
So my answer is going to be 0.8.
That's exact.
That is exact. All right, I'm going to do another one at the bottom of the page. I'm going to add one in. Okay, what place value is the last digit in? It's in the thousands. Is 1,000 a perfect square?
No.
No, it's not. So 1,000 is not a perfect square. We know that. Is 121 a perfect square? Yes, it is. It's in that list up above. But because it's in the thousandths place, and 1,000 is not a perfect square, this can't be a perfect square. So if I do that in my calculator, if I go square root of 0.121, that answer that I get, is that an irrational number? Yes. There's no pattern, it doesn't end. So this is 0.3479, and that is approximate. So the decimal ones are a little bit harder because I have to think about them. I got to figure out if they're in a place value that is square rootable. Is 10,000 a perfect square?
Yeah.
Yeah, it is. Is 100,000 a perfect square? No, so it's like it skips every other one. So, sorry, I'm up here. You guys don't have to write this down. I just picked it any decimal, as you can see. So you guys, this is the 10th place, right? Is 10 a perfect square? No. So that one's not going to work. Is the hundredths a perfect square? Yes. So this one will work. The 3, what's that one in? That's in the thousandths. I'm running out of room. Is 1,000 a perfect square? No, so that one's not going to work. 4 is in the 10,000s. What?
0.12 squared is an irrational number.
0.121. What are you talking about, bud?
Like you see here, you said the hundredths, it's gonna work, right?
Oh, I just used any decimal. I'm talking about the place values here,
Oh.
Rahat. That's all. I'm just talking about place values, not the actual number, okay? So 10,000 is going to be good. What about the 100,000s? No. And if I want to check that, that's easy enough to do. All I need to do is do the square root of 1, 2, 1, 2, 3. That's 100,000. Hit my equal sign, and I don't get a terminating decimal. I get an irrational number there. So 100,000s. 100,000s is a no-go. And so you see how it kind of skips every other one? It starts with a no, then a yes, no, yes, no, yes. So there's a pattern there. Okay, let's go back to filling out the chart. Cube root of 16. So I'm going to go up here. Is there a cube root? Is there 16 in here? No, there's no 16 in the cubes. So this means I'm looking for perfect cubes. The index is a 3, so I'm looking for perfect cubes. So I know my answer is going to be approximate. Even without solving it, I know that it's going to be approximate because there's no 16 in that list. Ooh. Oh, I did the square root. I need to do the cube root. So do you guys know how to do the cube root button? Some of you might have a cube root because it's pretty common. So you might have a 3 root on there. I think for you, Dion, you do. Under math, it's option 4.
Hey Dion, you're using a bracket calculator?
So again, no repetition here. It doesn't end. So this is an irrational number. So we're going to fill that in. 2.5198. Okay, cube root of 27. Cube root of 27. Is 27 in our perfect cube list? Yes. So what's the answer going to be? 3. I don't even need my calculator. All right. Is 16 a perfect cube?
No.
No, because we just solved that up here, right? It's not a perfect cube. So, right away, even though 81, is 81 a perfect cube?
Yes.
No, it is not.
No.
So it doesn't matter, they both have to be perfect cubes for it to be an exact value. Even if just one of them isn't, you're still going to have an approximate answer. So I'm going to get an answer of 0.582, and I'm going to round that up to a 4. All right, 64, is that a perfect cube?
Yes.
Yeah, it is. It is, which is awesome. What place value is that 4 in? It's in the hundreds. Is 100 a perfect cube? No. It's a perfect square, but do we see 100 anywhere in this list? No. So now it's kind of switched. So all those places that weren't good for the perfect squares, guess what they're really good for? 1,000 is a perfect cube. But alas, this is in the hundreds place. 100 is not a perfect cube, even though 64 is. So when we put this in our calculator, I get that sorry, the light's bright. I get that irrational number again. Because although this 64 is a perfect cube, the place value isn't. So this is going to be 0.8618, and that would also be approximate. All right. So I say this all the time in grade 12 and grade 11. I say leave your answers as exact values. So if I actually did this on my calculator, is that an exact value, the cube root of 16? No, it's approximate. So for my grade 11s and 12s, I asked them to leave it like this. I asked them not to go any further. Life without a calculator is pretty sweet. You don't have to do any extra math. Well, kids would disagree at this point. Okay, so that's your lesson for today. Super easy, kind of, sort of. As long as you know how to work your calculator, you should be good.